In this video, I'm going to talk about what makes a good statistical question. So not all questions are statistical questions, and not all questions can be answered well with statistical analyses. So some components that do make a good statistical question is they have to contain data. Now, what is data? Data can be numerical, and that's usually what people think about as data. So we're talking about numbers. We're talking about counting things. So that is one kind of statistical data. Another is categorical data. Categorical data just means words, categories of different things. So different kinds of animals. So we could have cats, dogs, fish, birds. Those are categorical data that we are collecting. So primarily in this course, we're going to be talking about numerical data because this is a math course, but just be aware that some data that we collect is categorical. Another point of a good statistical question is that we have to anticipate variability. So questions with one right or wrong answer, probably not a good statistical question. We want to have lots of different possible answers to our question so that we can measure that variability, that changing of the data in terms of numbers, usually. So let me give you two examples here of statistical or not statistical questions, and we'll see why they are good or not so good questions. So the first question here is, how heavy is Anith's backpack? Now, that contains data, right? It contains a measurement of the weight of Anith's backpack. However, it does not contain variability. This is what I'm talking about when I say a good statistical question has to have variability, because once we measure Anith's backpack, we get an answer, right? Unless we have a bad scale or something, we get one answer. This is how much is Anith's backpack, done. So this is not a good statistical question because we don't have any variability. Contrast that with a second question. How heavy are the backpacks of students in this class? Now we have data because we can collect the weight of a number of backpacks. So we have data, and it is numerical data. And we also have variability. And by that, I mean different backpacks of different students will have different weights. And we can do things like count the number of backpacks that all have the same weight. We can calculate things like mean or average. What is the average weight of a student's backpack in the class? We can chart or graph the different weights of the backpacks of students in this class. So this is a good statistical question.